So this is going to be kind of halfway through Chapter 1. There's 7 sections in Chapter 1. All of them, in some sense, deal with sets. And Section 1.4 is dealing with operations with sets, which are unions, intersections, and complements. Somehow it's going to be taking one set or multiple sets and creating new sets from the sets. And most every problem in this section is going to refer to something called a universal set. And a universal set is unique to a group of problems. A universal set for particular problems or a particular set of problems is a set that contains all the elements that all the sets in that problem are made up from. That's really a pretty awful definition. But nevertheless, once we get to the examples, it's going to be obvious what a universal set is. So a universal set is some big set that we're gonna make sets from the elements in that universal set. It's some global set in some sense. And a universal set is usually denoted by the capital letter U, but sometimes it's given by the Greek letter Z. I would never use this letter, but we'll see some examples that I pulled off the internet of universal sets that use this letter, so I felt obliged to make that little comment here, just because sometimes it's hard for me to create sets by myself, and searching Google Images I can find sets that are more interesting that I can create by hand. And so anyways, in this set we're going to create subsets from a universal set, and then we're going to use operations to create new subsets of the universal set from the subsets. That's so many words. That's not anything that you need to understand perfectly right now. As we go through the examples, what I just said will make more sense. So a universal set is just some global set that we're going to take and form subsets from, and then we're going to take those subsets and form them into other sets. There's 3 operations that we're going to learn in this section. And those operations are complements of sets, intersection of sets, and unions of sets. The complement of a set A is given the symbol A complement. So if I see this symbol, I would read that as A complement, or the complement of set A. And A complement is the set of all elements in the universal set that aren't part of set A. And again, the definition itself, if you knew what complement was already, the definition would make sense. If you don't know what complement is, it won't make so much sense, but as I go through the problems, these definitions will make more sense. I kind of need to say the definitions before I do the examples, and then once I do the examples, it'll make more sense what these words mean. So there's 3 different operations that we're going to do with sets. The first operation, or one of the 3 operations, is complement. The second of the 3 operations that we're going to learn is intersection. The complement refers to just the complement of a single set. The intersection is joining 2 sets together. So the intersections of sets A and B is given by the upside down U symbol. So this right here, I would read this as set A intersection set B. So I read this as A intersection B. So the upside down U is intersection, and A intersection B is a set containing all the elements that are in common to both sets A and B. So an intersection of 2 sets is just what the sets have in common. The third and last operation that we're going to get in this section is union. And the union also refers to 2 sets as opposed to 1 set like complement. The union of 2 sets A and B is symbolized by the right side up U. So this symbol right here, I would read this as A union B. So the 3 symbols that we have a complement symbol, a intersection symbol, and a union symbol. And Complement is everything in the universal set that's not in the set named. Intersection is everything the two sets named have in common. Union is the third of the operations, and A union B is a set containing all the elements that are in set A or set B, or that are in both sets A and B. Unions generally get bigger. Intersections get smaller. Complements, it's harder to say if the set gets bigger or smaller because it depends. But let me just try to do some examples to help you understand what these terms mean. So first term we talked about was a universal set. And for this example right here, I created a universal set and two subsets of the universal set, set A and set B. And I just randomly made this up. So this set U is called a universal set for this particular example. So for this example, the only numbers I'm going to consider are the numbers 1, 2, 3, and 5. Set A and set B are subsets of this universal set. They're actually proper subsets because they don't equal the set. The first thing I ask you to find is the complement of A. And the definition of the complement of A will help me find it. The complement of set A is all the elements in the universal set that aren't in A. So A has the numbers 1, 2, and 3. To find A complement is all the elements in the universal set that aren't in A. So if I simply go to the universal set, if I'm trying to find A complement, and I cross out any elements in the universal set that are in A, I'll be left with the elements of the universal set that aren't in A. And that's what the complement of a set is. The complement is every element in the universal set that aren't in the given set. So the complement of A, or A complement, would be the set that contains the numbers 4 and 5. Complement for me is a really easy operation. We have 3 set operations. Complement is easy. Intersection is easy. Union can be a little bit tricky. So I just wrote down here, A complement is all of the elements in the universal set that aren't in set A. 1, 2, and 3 are in the universal set, but they are in set A, so they're not in A complement. 4 and 5 are in the universal set. They're not in set A, so that's all what A complement is. The next thing I ask us to do is find A intersection B. And A intersection B is what the elements that are in common between both sets A and set B. Super easy to find the intersection of sets A and set B. If I look at set A has the numbers 1, 2, and 3. Set B has the elements or the numbers 2, 3, and 4. A intersection B is what they have in common, and what they have in common, they both have a 2, they both have a 3. A intersection B is going to be the set that contains what they have in common, which is 2 and 3. And I wrote the answer down already. I guess I don't need to write it again. But how I got the answer to what A intersection B is as a set, I looked at both sets A and set B, and the 2 elements that they had in common, I created a new set, and I called it A intersection B. So complement is easy. It's everything in the universal set that's not in the set that you're complementing. Intersection's kind of easy too. It's just what the 2 sets have in common. The third operation is the operation where if you're going to mess up, this is probably where it's going to mess up. So the next thing I want to do is I want to find A union B. And what A union B is, it's listing all of the elements that are in set A, or in set B, or in both. And one way I try to find a union, or a way that I find the union, and I find it to be followable for students, to find A union B, I form a big set. And how do I form that big set? I start off by writing my set braces, and the first thing I will write is all the elements in set A, which are the numbers 1, 2, and 3. And then after it, I'll write all the numbers in set B, which are 2, 3, and 4. This is technically what A union B is. A union B takes the entire A set and joins it together in a gigantic set with all the elements of B. Of course, this isn't the best answer because when you're writing sets, it's not necessary to write an element more than once. So A union B is asking me to list all the elements of A followed by all the elements of B, then to delete any elements that are written twice, but only delete them once and leave one of them. So because there's 2 2's and 2 3's, when I go to write my answer for A union B, I took all of A and all of B, and I deleted one of the 2's and one of the 3's and left myself with 1 2 and 1 3. A union B is going to be 1 2 3 and 4 instead of 1 2 3 2 3 and 4. I don't need to write the 2 and 3 twice. That's all there is to do for this section. Of course, there's going to be some orders of operations that we'll have to deal with, but that's exactly what the 3 operations that we're going to deal with. We're dealing with complements, unions, and intersections, and that's all that there is. Actually, for the next few sections, that's all there's going to be is complements, unions, and intersections. So let's try to get good at finding complements, intersections, and unions. And I made up a new universal set for this next example. So I made a universal set that has the letters A, B, C, D, and F, and I made the subset A and the subset B again, and I just made those up, just randomly. I don't know why they both have 3 elements, A and B, but they do. I mean, A could have 1 element and B could have 5 elements. It doesn't matter. I just randomly made up these sets. Now I'm going to try to find a new set, A complement intersection B. And anytime there's a complement, you have to do it first. So in my orders of operations, complements will be done absolutely first. So the first thing I did to figure out what A complement intersection B is, I told myself first I need to find out what A complement is. And what is A complement? It's all the elements in the universal set that aren't in set A. So if I take set A, which is A, B, and C, and just mark that up in my universal set. What's unmarked is what A complement is. So A complement is going to be the set that contains D, E, and F. It's the letters in the universal set that aren't in set A, which is D, E, and F. So that's the first thing I'm doing. In order to find A complement intersection B, I had to find A complement first. And I just wrote down here, I typed it down, that A complement is the set that contains D, E, and F. Now, after I did complement, the second thing I can do is this intersection. I'm going to work from left to right now that I have the complement done. And so how do I do the intersection? So now I can intersect the 2 sets. So I'm going to intersect the set A complement with the set B. Well, I know that A complement is the set D, E, and F. And I know that B is the set C, D, and E. So I'm taking these symbols, the A complement symbol and the B symbol, and I'm replacing them with the sets that they're equal to, because it's going to help me to find out what A complement intersection B is. If right next to each other I have the set that's equal to A complement, D, E, and F, and the intersection sign followed by the set B, which is C, D, and E. And now to find the intersection, that's super easy, because the intersection of 2 sets is what the sets have in common. So I look at the 2 sets that I've created, and I look, what do they have in common? Left set has a D, right set has a D. That has to be part of the set that I'm creating for the answer. Left set has an E, right set has an E. That has to be part of my answer. Those are the only 2 letters that they have in common. That's going to be my answer. So A complement intersection B is what the A complement set and the B set have in common, and what they have in common is D and E. So for an answer, I just wrote the set D, E. This is completely fine. This is probably how I would generally write the answer. If you wanted to, you could write the problem and then the answer. So you could actually have written in your answer, or I could have written that A complement intersection B is the set that contains the letters D and E. All right, for these same 3 sets, U, A, B, C, D, and F, A being A, B, and C, and B being C, D, and E, I want to now find A complement union B. A union B complement, should I say. And I've got to do complements first. So if I'm asked to find the union of two sets and one of the two sets is a complement, I have to figure out what the complement is. And it's real easy to find B complement, because to figure out B complement, I'm just going to look at set U, and B complement is going to be all the elements in set U that aren't in set B. Well, there's set B, C, D, and E. So B complement is going to be the set that contains A, B, and F, because those are the letters that are in the universal set that aren't in set B. So the first thing I wanted to do is find B complement, and B complement is A, B, and F. Now I can do the union. So complements are always going to be done first. Any problem that has a complement, I'm going to need to figure out what that complement is very first. Now I can do the union. And what am I going to union? Well, I'm going to union A with the set B complement. And in order to union two sets, I usually like to know the elements that are in each of the sets that I'm unioning. Well, set A has the letters A, B, and C. I'm going to union that with set B complement, which has the letters A, B, and F. And when I union two sets, I take all of the elements in the first set, followed by all of the elements in the second set, and write them in a big, big set. That's technically the answer to this problem, but it's not written in the best way because I have some duplicates. And any letter that's written twice, I'm going to not write twice. There's two A's, so I'm only going to write one A in my answer. There's two B's in this set, I'm only going to write one B in my answer. My answer to this problem as to what A union B complement is, I'm going to say it's the set that contains the letters A, B, C, and F. If you can do these problems in your head and you don't have to show this intermediate step to find the union of the two sets, that's better than writing all the steps that I'm writing. The rest of what I have written on this page is exactly this. A union B complement is set A, followed by set B complement. I take all of the 6 items, the 3 from set A, followed by the 3 from set B complement. I write them in a big set, and I delete. If there's any duplicates, I only write one of them in my final answer, so I don't need to have 2 A's and 2 B's in the set, and there's my answer. Now we get to do some homework problems. The first 10 homework problems in this set give me, I don't know if these are exactly the same sets that we've been working with, but they feel pretty much so the same. So let me do problem 2 while you do problem 1. So for problem 2, I need to find B complement. Well, B is set A, C, and D. To figure out what B complement is, I'm going to go to the universal set, and I'm going to cross out any of the elements that are in set B, which is A, C, and D. What's left when I cross out those 3 letters is what B complement is. My answer to question 2 is the set that contains the letters B and E. So you should be able to do number 1. When you go to do your number 3, you can jump right into doing the problem. When I go to do number 4, because I have complements, complements need to be done first. And if there's 2 complements, you'll go from left to right. So when I do number 4, the first thing I need to find is what A complement is. And A complement is what I get when I take C, D, and E and remove them from the universal set. A complement is going to be the set that contains A and B. So to the right of the equal sign that I just wrote, I wrote down what A complement was. That's the first thing that I did. I'm going to leave the union symbol. The second operation I'm going to do is I'm going to find B complement. The reason I left my other sheet up because I already found B complement for this group of this set. So B complement is B and E. So I've done the 2 complements. After I do the complements, now I can do the union for my problem 4. A complement union B complement is going to be the set that has the 2 letters from the first set, followed by the 2 letters from the second set, and then I delete any extras. I don't need to have 2 B's in my answer. When I go to write my answer, I usually would just write the set down that has been created without the problem written next to it. So my answer would say it's the set that contains A, B, and E. But I absolutely could have said the A complement union B complement is the set that contains the letters A, B, and E. Those would be equally correct. I'm going to move on and do 6, and you can do 5. Your 5 is easier than my 6. Immediately, my 6 has complements in them. I need to know what A complement is first, and what B complement is second, and then I'm going to do the intersection. I left my other sheets up here because I already know what A complement is and what B complement is. I don't need to figure those out again. So as I go to do my work here, I'm going to figure out A complement first. A complement is the set that I figured out in problem 4, which is the set that contains the letters A and B. I'm going to keep this intersection symbol, and after this intersection symbol, I'm going to write what B complement is, and I figured out B complement had the letters B and E. And now I'm going to intersect these two sets. Intersections are much easier than unions for me. Intersections are what sets have in common. My answer to this is what these two sets have in common, which is just the letter B. My answer is the set that contains the letter B. And I absolutely, if I really care to, I could have written the problem saying A complement intersection B complement is the set that contains the letter B. You don't have to write the problem with the answer, but you certainly can. So you probably can do, problems 3 and 5 without showing all the work that I'm showing, and the less work you show, probably the better. All right, let me do 7 for you, even though you probably could do 7 without me. So if I was asked to do 7, first thing I need to do is the complement of A. I already know the complement of A, but I didn't leave it on this sheet. The complement of A is all the letters that are in the universal set that aren't in set A, which are the A and the B. So this problem right here, I'm going to do A complement, which is the letters A and B, the set containing those, intersection, and I can leave set B alone. Set B has the letters A, C, and D. And when I intersection, I look to see what sets have in common. The only letters those have in common are the letter A. When I go to write an answer for number 7, I would probably just say it's the set that contains the letter A. But if that bugged me and I wanted to write a nicer looking answer, I can write the problem followed by an equal sign, and then what the answer was the set containing A. So 9 and 10, and then my video is going to hiccup and we'll get to another group of problems with another universal set. So for number 10, I'm doing A union B complement. The first thing I need to know is what B complement is. I already know what that is, but I'll pretend I didn't remember. B complement, this set right here, is the set containing the letters B and E. So what I'm going to do now is I'm going to union the set A, which is the set that contains the letters C, D, and E, with the set B complement, which is a set that contains the letters B and E. And remember, when I union two sets, I take the elements in the first set, followed by all the elements in the second set, and then any letter that's written twice, I only leave one of them. And then it doesn't matter the order that I write the sets in, the letters in, but I like writing them alphabetically. It would be completely fine for this problem number 10 if I said the answer was C, D, E, and B. If that bugged me, I absolutely could write B, C, D, and E. And if it bugged me that I didn't have the problem written next to the answer, I could write A union B complement is whichever one of these, I find most appealing. So there's varieties of answers that are okay. What every correct answer for number 10 has in common is it has the same 4 letters in the set, whichever order you decide to write them in is kind of up to you. All right, so you very well might be able to do a lot of the problems that I'm about to flash up without me explaining how to do these problems. So let me show you the next few problems that you're going to be asked to do. If you want to, pause the video, try to do those problems, and don't even watch me explain how to do the other problems so you can save some time. I'll go ahead and do all the other problems, all the even problems. So 12 wants me to find B complement for these new sets. B is just the number 5, or the set containing the number 5. B complement's going to be the set containing the numbers 1, 2, 3, and 4. It's everything in the universal set that's left when I take out the element of B. When I go to do problem 14, I need to do A complement union B complement. I need to first figure out what A complement is. To figure out what A complement is, I take the 3 elements in set A, remove them from the universal set. I'm left with 4 and 5. That's what A complement is. A complement is the set that contains the numbers 4 and 5. I'm going to leave my union symbol. And then after my union symbol, I'm going to write B complement. And I just figured out B complement is the set that contains the numbers 1, 2, 3, and 4. And now I'm going to union these two sets by taking all the elements in the left set followed by all the elements in the right set. So I made a set that had 6 elements, the 2 from the first set, the 4 from the second set. If anything's written twice, I want to count out one of them and only write it once. So my answer, or an OK answer, would be the set containing 4, 5, 1, 2, and 3 for number 14. I almost never write the original problem with my answer, but I almost always, if there's numbers, write them in order. And so I'm going to write for my answer to number 14 the numbers in order. All right, so give 13 a go if you haven't done it already. For my problem 16, I need to figure out A complement intersection B complement. I need to know what A complement is. A complement had the numbers 4 and 5 in it. So I'm going to do A complement, which is a set that contains the numbers 4 and 5. I'm going to intersection that with B complement, which is the set that contains the numbers 1, 2, 3, and 4. And intersection are what sets have in common. And what these two sets only have in common is the number 4. My answer to problem 16 is going to be the set that contains the number 4. And again, if it bugs you to not have the problem written next to the answer, you absolutely could take the time to rewrite your problem or your answer so it had the problem next to the answer. Alright, so let me work on 18. In fact, let me work on 17, so we'll save you a step here. So 17 first wants me to find A complement. If I didn't know what it was already, I could find it real quickly. A complement is the set containing 4 and 5. I'm going to intersection that with the set B, which is a set that contains the number 4. And for number 17, when you intersect two sets, you just write what they have in common. These both have the number 5. My answer is going to be the set that contains the number 5. If there wasn't anything in common, like if this set just had the number 3 and there wasn't anything in common, your answer would be the empty set. All right, 1920, and then we're going to get into working with 3 sets as opposed to just sets A and B. We're going to toss on a set A, B, and C. So 20 is A union B complement. I need to do B complement first. B complement is 1, 2, 3, 4. So I'm going to take set A, which is a set containing the elements 1, 2, and 3, and I'm going to union that with the set B complement, which is a set that contains the numbers 1, 2, 3, and 4. And again, when I union two sets, I take all the elements in the first set and all the elements in the second set and write them in a big set. So this set's going to have 7 elements. And any object that's written twice, I only write it once. And there's 2 1s, there's 2 2s, and 2 3s. I'm only going to write those once. And for 20, the answer I'm going to write is going to be the set that contains the numbers 1, 2, 3, and 4. there isn't going to be anything new when we get to working with a universal set that has 3 subsets, other than orders of operations. There might be some parentheses here that we have to worry about, but in general, we will work problems that have 3 sets from left to right. Of course, if there's a complement, I have to do it first. So the first thing I did is I made up a new universal set that has the letters A through F, and I made up some subsets, and I want to find A union B union C, and I'm going to work from left to right. So how do I work from left to right? Well, working left to right, first I have to find A union B. And how do I find A union B? Simple. I take the 3 elements of A, B, and C, and the 3 elements of B, C, D, and E, and I write them in a big set, but I look for any duplication, and if there's duplication, I cross out some of that duplication and not write it. So A union B is C, D, A, B, C, D, and E. So what I've done is I can change this problem to this. The A union B part turns into the set containing A, B, C, D, and E. So I'm going to replace the A union B symbol with the set that it's equal to, and then I'm going to do the union C. So I'm working from left to right. I took the first 2 sets, I made them into a single set, and made it into a bigger set because it was a union. Now that I've got the problem down to this, I'm going to do the union C part. And how do I do the union C part? Well, I just simply take the C and write down what it's equal to. This C is equal to D, E, and F. And so I'm taking the set that's equal to A union B, which is a set that has the letters A, B, C, D, and E. I'm going to union that with the set that contains C, which is a set that has D, E, and F. And how do I union? Simple. I take all the elements in the first set, write them down. All the elements in the second set, write them down. Then I have a set that's too big. I look through the set for any duplication. Any letter that's written twice, I count out one of them. There's 2 D's, I'm going to cross out one of the D's. There's 2 E's, I'm going to cross out one of the E's. What's left is going to be the final answer to this. And what's left is A, B, C, D, E, and F. That's the answer to what A union B union C is. So there isn't anything new. The only operations we're ever going to have are complements, unions, and intersections. The only thing that's going to get more complicated is orders of operations. When you have more sets, we have to worry about more orders of operations. Complements are generally done first unless they're outside of parentheses. And in this example right here, a parentheses gets done before a complement. So just like, a complement's kind of like an exponent, and in the PEMDAS, or the Please Pardon My Dear Aunt Sally, parentheses are first, exponents are second. Parentheses are first, complements are second. A complement is kind of almost looks like an exponent, so with orders of operations is working like an exponent. So to find B union C first. So that's my orders of operations here. So first I have to do the inside of the parentheses, which is B union C. And how do I find B union C? Well, I take the elements of B, which are C, D, and E, the elements of C, which are D, E, and F, and I write them in a big set. So I took the elements of B, C, D, and E, the elements of C, D, E, and F, and I put them in a big set. I call that B union C. I took those 3 elements, followed by those 3 elements, and then I looked for duplication. There are 2 D's, I only need 1 D in my answer. There's 2 E's, I only need 1 E in my answer. So as I went to write an answer for what B union C is the set that contains the letters C, D, E, and F. So the inside of this parentheses I know is the set containing C, D, E, and F. And so now I'm going to do the complement. So I've done the inside of the parentheses. Really what I have now, what I should have written here, is what I'm doing is I'm taking the set C, D, E, and F complement. This is exactly what I have to do to finish this problem. To do B union C complement, I need to do the complement of the set C, D, E, and F. And how do I find a complement? I look at the original set, and from the original set, the original universal set, I take out that set. So I took C, D, E, and F from the universal set. I'm going to be left with A and B. And this is why in my answer I have just A and B, because the universal set, it was the set that contained A, B, C, D, E, and F. To find the complement of that set, I just simply cross out C, D, E, and F from the universal set. What I haven't crossed out is going to be what's in the complement of that set. So my answer is just A and B. Another example. You'll notice that this example has a component that's equal to the last example. Of course, I need to do parentheses first. So if I wanted to find A union B union C complement, the first I need to simplify the inside of the parentheses first. The parentheses is B union C complement, and I just figured out that that's the set that has AB. So that work is made easy for me. So the first thing I'm going to say, I'm going to do this parentheses first, and this parentheses I just figured out to be the set containing A and B. So now I can do the union part. And how do I union set A with B union C complement? Well, I write down what set A was, which is a set containing A, B, and C, followed by what B union C complement is, which is A and B. And how do I union two sets? I take all the elements of the first set, A, B, and C, followed by all the elements of the second set, A and B. I write them down in a big set, and any letter that's written twice, I cross out one of them and only write that letter once. Since there were two A's and two B's, I only wrote one A and one B in my answer. My answer to what A union B union C complement is the set containing the letters A, B, and C. Another example, I better pull this set back up. Let me just write what the universal is here. The universe for this problem is that A, B, C, D, E, and F, and A is the set A, B, and C. B is the set C, D, and E, and C is the set D, E, and F. So this is an orders of operations problem, and always, when we have parentheses, we need to do the parentheses first. So I need to simplify the inside of the parentheses very first, which is B intersection C complement. Well, inside that parentheses, I have to know what C complement is. So how do I find the C complement? Well, I look at C, cross it out from the universal set. C complement is going to be the set A, B, and F. So when I go to work on the inside of that parentheses, I have to do the complement first, which is, this is wrong. I was supposed to cross off D, E, and F, and I didn't. Let me recross that out. C is D, E, and F. C complement is supposed to be A, B, and C, not A, B, and F. There's my bad there. So working on the inside of this parentheses, I need to do B intersection C complement. B is the set that can has C, D, and E. I left the intersection, and then I wrote down C complement as A, B, and C. And how do I do intersection? Intersection is what the sets have in common. Both sets have a C, and that's the only letter set they have in common. So the B intersection C complement, this whole parentheses is going to simplify to the set that just contains the letter C. So now I'm able to drop out the parentheses. And so I took the original problem, and in my original problem it had a parentheses, but I know that that parentheses is equal to the set containing C, and so that's what I wrote on my next line. So I got my parentheses done. Now I can do A complement intersection that set, but I don't know what A complement is just yet, so let me figure out what A complement is. The universal set has the letters A, B, C, D, E, and F. A has the letters A, B, and C in it, so A complement is going to have D, E, and F. So when I'm intersecting A complement with B intersection C complement, I'm taking the set A complement, which is the set D, E, and F, and I'm intersecting that with what B intersection C complement is. And when I look at those two sets, they don't have anything in common. So my answer is what they have in common. When they have nothing in common, you can write your answer one of three ways. You can say it's the empty set like that, or you can say it's the empty set like that, or you can write the words empty set. All three of those would be correct answer because there's nothing in common in that final intersection. All right, now we get to muscle through some more complicated problems. So let's I'll work on 22. 22 wants me to find B intersection C. B is the set that contains the numbers 2, 3, and 4. I'm going to leave the intersection symbol. C is the set that contains the numbers 1 and 5. When I intersect those two sets, I need to find out what they have in common. Because they don't have anything in common, my answer needs to be something that means the empty set. I could write that for my answer for question 22, or I could write that for my answer, or I could write the word empty set. One of those three answers needs to be done. When you do your answer for 21, you're not going to get an empty set for your answer. So I'll move on to do 24. 24 wants me to take set B, which has the numbers 2, 3, and 4, and union that with the set C, which has the numbers 1 and 5. When I union two sets, I take every element in the first set and I write it down, followed by every element in the second set. Usually there's duplication, but there isn't any duplication here, so there isn't anything to cross out. This is an okay answer for what problem 24 is. Of course, I don't like to have my numbers written in a funky order like that. I probably would take the time, if I was doing problem 24, to write my numbers in ascending order. So your 23 should be real similar. Now I'm going to move on to do problem 20. Let's do 25 together. I won't do 26 just in case this is confusing. So there isn't any parentheses, there isn't any complements. I'm going to work left to right. So the first thing I'm going to do in problem 25 is figure out what A intersection B is. So to do A intersection B, I'm going to take set A, which has the numbers 1, 2, and 3, and I'm going to intersect that with set B, which is a set that has the numbers 2, 3, and 4. Intersecting are what sets have in common, and those two sets have 2, 3 in common. So instead of saying A intersection B union C, I'm going to change this to what A intersection B is, and A intersection B is 2, 3. So these symbols right there, I'm going to change to the set containing the numbers 2 and 3. I'm going to leave my union sign and I'm going to leave my C. Now I'm going to figure out what this equals to by taking the set A intersection B, which is a set containing 2 and 3, and I'm going to union that with set C, which is a set that contains 1 and 5. When I union two sets, I take all the elements in the first set, I write them down, and then I take all the elements in the second set and write them down. I take out any duplication. There isn't any duplication to take out. I could call that my answer, but it's certainly not that hard to write these numbers in a nice order, and I prefer the numbers written in a nice order. So I would say the answer to problem 25 is the set containing the numbers 1, 2, 3, and 5. I like it when there's no parentheses and I can just work from left to right. I'll do 28 and give 27 a chance. The first thing I'm going to do in 28 is find B intersection A. So let me find B, what B intersection A is. B intersection A I get by taking set B, which is the numbers 2, 3, and 4, and intersecting it with set A, which has the numbers 1, 2, and 3. When I intersect those two sets, I write what they have in common, which are the numbers 2 and 3. So this right here, I'm going to change to the set containing the numbers 2 and 3, union with C. So I'm working from left to right. I got those two down to a single set. Now I need to do the union C. To do the union C part, I need to change the C to what it's equal to. C is equal to the set that has 1 and 5. Just feels like the same problem that I just did. Well, it's very similar. It's just written slightly backwards. And when I union these two sets, I take all the elements in the first set, followed by each of the elements in the second set, form them in a big set. I would cross out any duplication if there was duplication. There isn't any duplication, so I'm just going to take the numbers and write them in a nice order. 30 I can do. A intersection B complement. I better find out what the complement for 30 is first. The complement for this right here feels like I have new sets here. Are they the same? Oh, they're just the same. So to do the complement, I take 2, 3, and 4 away from the universal set, and what I'm left with is 1, 5, and 6. So when I'm asked to do a problem with a complement, I need to know what that complement is first. In this problem, I'm going to take set A, which has the numbers 1, 2, and 3. I'm going to intersect that with the set B complement, which is a set that has the numbers 1, 5, and 6. Now I'm going to find out what they have in common, because intersections are what they have in common. My answer to problem 30 is just going to be the set that contains the number 1. I almost never write the original problem followed by my answer. I usually just write what the answer is, just because I don't need to write down the original problem. It's not necessary, and I don't want to write more than, I have to, I guess. So your 29 should work similarly. For both 31 and 32, we're just going to work from left to right because there aren't any parentheses. And let me do 31 with you just so we can walk through that together. So for 31, the first thing I need to do is A complement union B. I need to know what A complement is. I figure out what A complement is by taking 1, 2, and 3 and crossing it out from the universal set. A complement is going to be the set that contains the numbers 4, 5, and 6. So to do the A complement union B part of this, that's going to be taking set A complement, which is 4, 5, and 6. I'm going to union that with set B, which is the set that contains 2, 3, and 4. And of course, when I union two sets, I take every element in the first set, followed by every element in the second set. If any element's written twice, I cross out one of them, only leave it written once, and then I like to write the numbers in a nice order, or the letters in alphabetical order. So the A complement union B part of this is going to be that set 2, 3, 4, 5, and 6. So this is kind of side work, and now I can start doing the problem. So the A complement union B, I'm going to change to the set 2, 3, 4, 5, 6. And then I'm going to leave the intersection C complement. So I need to know what to put in place of that C complement. I'm going to go to the universal set, and from the universal set, I'm going to take the 1 out, and I'm going to take the 5 out, because that's what C is. And what's going to be left is a 2, 3, 4, and 6. So the set C complement, I didn't give it to you. I had to figure it out. It's the set that contains the numbers 2, 3, 4, and 6. So coming back to what I'm trying to do, I'm taking the first set that I created, A complement union B, which is 2, 3, 4, 5, and 6. I'm going to intersect that with C complement. So I'm going to take the set 2, 3, 4, 5, and 6. And I'm going to intersect that with the set C complement, which is 2, 3, 4, and 6. And when I intersection, I find out what they have in common. They both have a 2, they both have a 3, they both have a 4, and they both have a 6. The answer to this problem is going to be those 4 numbers that they have in common. The answer is going to be the set that contains 2, 3, 4, and 6. That's the answer to number 31. There's a monstrous amount of problems. We go all the way, oh my gosh, all the way up to problem 53. So we've got a chunk more problems. It's just all orders of operations, really. So let's deal with 33 and 34. I'll do 34. I have a new universal set for these problems. So in 34, I find B complement first. B complement is found by taking the elements in set B and crossing them out from the universe. So B complement just has the letter A. So in my problem 34, I'm going to take B complement, which is a set containing the letter A, and I'm going to intersect that which set C, which is a set containing A and D. When I intersect, I find out what the sets have in common, and they both have the A in common. My answer to problem 34, B complement intersection C for these new sets, would be the set just containing the letter A. So you should be able to make a good stab at 33. 36, I need to know double complements. I need to know what B complement and C complement is. B complement is going to be just taking the B, C, and D out of the universal set. It's going to be giving me the letter A. So B complement is going to be A. And C complement is what I get when I take A and D from the universal set, and that leaves me with B and C. So when I go to do a problem that has complements, I better figure out what those complements are. So I'm going to take B complement, which is the letter A, and I'm going to union that with C complement, which is a set that contains the letters B and C. To form the union of two sets, I take every element in the first set, write it down, and then the elements in the second set, write them down. Usually, I've got more work to do. Usually there's a letter that's written twice that I have to only rewrite once, and usually the things aren't written in a very nice order. I usually take the time to write them in a nice order. In this case, that's actually the answer. There's no letters in that set that's written more than once to cross out, and the letters are written alphabetically. I feel good about that. Let's do your 37. You can pause the video and give 37 a try, and then you can watch me do it if you can't. First thing I need to do is work left to right. I'm going to do A complement intersection B. I better figure out what A complement is. A complement is what you get when you take the A, B, and C away from the universal set. A complement is just going to be the set that contains D. So let me go way out down here off to the side. To figure out what A complement intersection B is, I take A complement, which is a set that has the letter D. I intersect that with the set B, which is a set that has B, C, and D. And of course, when you intersect, you find out what the sets have in common. These two sets have the letter D in common. So the A complement intersection B part has just the letter D. So as I go to do this, for this part, A complement intersection B, I'm going to change that to the set that has the letter D. And then I'm going to union C complement. I need to find out what C complement is. The universal set has A, B, C, and D in it. When I go to find C complement, I take out the A and the D. C complement is going to be the set that has B and C. So now I'm going to take the set that's equal to A complement intersection B, which is just the letter D, and union that with the set that's equal to C complement, which is B and C. I'm going to take the element in the left set and the two elements in the right set and write them together. See how my set braces get really horrible as I speed up. That's a correct answer. There's no duplicates to cancel out, but I like taking my letters and writing them alphabetically. So when I would write an answer for problem 37, I would probably say it's the set that contains the letters B, C, and D. All right, I'll do number 40. To do number 40, I'm going to work left to right. There's no parentheses. The first thing I need to find out in problem 40 is what B complement intersection A complement is. To figure out what B complement is, the universal set is A, B, C, and D, and B is B, C, and D. So if I take B, C, and D away from the universal set, I'm just left with A. So the B complement just has the letter A, and then I'm going to intersect that with A complement. A complement you get by taking A, B, and C from the universal set, and when I do that, A complement is just going to be D. So what I'm doing is I'm intersecting these two sets. I'm finding what these two sets have in common. They have nothing in common, so the answer is the empty set. It's probably going to be nicest to write the empty set like that. So as I go to do number 40, this right here, the B complement intersection A complement, is going to be the empty set. And I'm going to union that with the set C. So this is equal to that. And now I have a union in a set C. So I'm going to take the empty set and I'm going to union that with the set A and D. And how do I form a union? I take all the elements in the first set, which is nothing. And then after it, I write all the elements in the second set, which is A and D. When you union the empty set with a set, you just get the set you're you were joining it with. So I feel like Porky Pig. This will be my answer to number 40. Because I take every element in that set, which is nothing, and then the elements of that set and join them together. Ugh, I'm getting tired of doing this. Let's just keep plodding along. So I'm going to do 42, which is probably easier than your 41. I need to do A intersection B complement. To do B complement, I'm going to take B, C, and D from the universal set. B complement is just the set that contains the letter A. So I'm going to take set A, which is the set that contains the letters A, B, and C. I'm going to intersect that with the set B complement, which is the set that just contains the letter A. And when you intersect, you write what the sets have in common. So my answer to problem 42 is just going to be the set that has the letter A, because those two sets that I'm forming the intersection of have A in common. Your 41 should work similarly. All right, well, 43 looks harder than 44. Let me do 43 with you. Again, you could pause the video and do 43. Check your work to mine. So first I'm going to do A complement union B complement. I need to figure out what A complement is, and I think I can do that without destroying the set. So the universal set has A, B, C, and D. If I take A out of that, I'm going to be left with D. So A complement is the set that contains the letter D. B complement is what you get when you take B, C, and D from the universal set. B complement has the set A. So the first thing I need to do is figure out what A complement union B complement is. A complement is the set that contains the letter D. B complement is the set that contains the letter A. And when I union those two sets, I take the elements of each set and join them together, and then there's no duplication there, but I'm going to take the time to write those in a nice order. So this thing that I have highlighted in blue is A complement union B complement. That's going to be the set A and D. So now I can rewrite this problem without that written without sets, and now I can write it with a set, and then it's going to be intersection C complement. And let me figure out what C complement is real quickly. C complement, I just take the A and the D from the universal set. I'm left with B and C. So what I need to do is take the first set that I figured out and intersect that with the second set, B and C. I need to find out what those sets have in common, and they don't have anything in common. So my answer needs to be some form of the empty set. You can write your answer like that, or you can write your answer like that, or you can write your answer using the word empty set. They're all equally good answers. You just have to decide which one you prefer and just stick with it. All right, getting to the end, it says 45 to 56. It feels like the problems end at 53. No, they go to 56. I take that back. So we've got problems with parentheses. I need to do the parentheses first. So off to the side, I'm going to, in problem 46, figure out what S union T is. S is going to be the set that contains 2, 4, and 6. T is the set that contains 1, 2, and 4. When I union these two sets, I'm going to take the 3 elements in the first set, and then I'm going to write the 3 elements in the second set. That's technically S union T. Finally, I have some duplication. I've got 2 2s and 2 4s. I only need to write one of each. And I'm going to write these in a nice order. So I'm going to say that the first thing that I have highlighted, the S union T in a parentheses is going to turn to the set 1, 2, 4, and 6. I don't need to write the parentheses anymore now that I have those two sets condensed down to a single set. So my first step in problem 46 is going to do the parentheses. Your first step in problem 45 is going to be able to do that parentheses. Now I have the parentheses done. I need to do the ending intersection V. So I'm going to take what S union T is, which is 1, 2, 4, and 6, and I'm going to intersect that with V, which is the set 4, 5, and 6. And of course, when I intersect, I write what they have in common, and these two sets, what they have in common is 4 and 6. My answer to problem 46 is going to be the set that contains the numbers 4 and 6. I almost think your 45 is easier, but I could be wrong. Let me do 47 with you as opposed to 48, just so we knock out some of your homework just to save yourself a little bit of work. There's a parentheses. I need to do the inside of the parentheses first. I'll do it off to the side here. So S union T is going to be the set S, which is the numbers 2, 4, and 6, union with the set T, which is the numbers 1, 2, and 4. When I union those two sets, I'm going to write 2, 4, 6, 1, 2, and 4. Any number that's written twice, I'm going to cross out one of them, only write one of each, and I'm going to write the numbers in a nice order. So S union T, I'm going to write as 1, 2, 4, and 6. So now in problem 47, I'm finding the complement of the set that contains the numbers 1, 2, 4, and 6. And to find the complement of that set, I go to the universal set. I cross out the 1, 2, 4, and 6. What I have left is going to be the complement of that set, and it's going to be my answer. My answer is going to be the set that has what's left when I cross out 1, 2, 4, and 6 from the universal set, and that's going to be the numbers 3 and 5. Ooga, ooga, ooga. All right, so let me do 50. Let me do the inside of the parentheses first. So inside of my parentheses in problem 50, I have to do S complement intersection V complement. S complement is what I get when I take 2, 4, and 6 from the universal set. And when I take 2, 4, and 6 from the universal set, I'm left with 1, 3, and 5. T complement is what I get when I take out 1, 2, and 4 from the universal set. So I'll take out 1, 2, and 4 from the universal set. T complement is going to have 3, 5, and 6. So to do the inside of my parentheses, I had to figure out what S complement and V complement were. I wrote down what S complement is, followed by V complement. And to intersect these two sets, I need to write what they have in common. And what they have in common is the numbers 3 and 5. So the inside of my parentheses, I can change to the set that contains the numbers 3 and 5. And once I get the inside of the parentheses down to a single set, I don't need to write the parentheses anymore. So I'm going to do the set containing the numbers 3 and 5, union T. T is the set containing 1, 2, and 4. So to get my answer, I need to take that set, union it with T, and of course when I union two sets, I take the elements in the first set, followed by the elements in the second set, make them into a big set, cross out any duplication, but there's no duplication there. I like writing my answer in a nice order, so I'm going to take those numbers and write them in a nice order, and I think that's just going to be 1, 2, 3, 4, and 5. Although this would be an okay answer as well, because it's a union that's written in an odd order, but it's fine. Our problems are a little bit different, so let me do your 51. Again, pause the video if you want so you can see how and work it out, and then watch me work it and make sure you do it the same way. First thing I need to do is the parentheses. The parentheses is S complement union V complement. So let me figure out what that is, what S complement union V complement is. S complement is what I get when I take 2, 4, and 6 from the universal set, which is going to be the numbers 1, 3, and 5. V complement is what I get when I take 4, 5, and 6 from the universal set. And when I take 4, 5, and 6 from the universal set, I'm left with 1, 2, and 3. So S complement union V complement is unioning those two sets. To union those, I'll take all the elements in the first set, followed by all the elements in the second set, get rid of any duplication omitted, and write the numbers in a nice order. So S complement union V complement is the set containing 1, 2, 3, and 5. So now I can get rid of the parentheses, and in place of S complement union V complement, I'm going to write the numbers 1, 2, 3, and 5 in a set, and now I'm going to intersection that with T. To intersection that with T, I'm going to intersect that with the set containing the numbers 1, 2, and 4. And intersecting is what sets have in common. Both the sets have 1 and 2. My answer to problem 51, or your problem 51, is the set containing the numbers 1 and 2. So hopefully, although these are tedious, maybe they're not that hard, because it's just, just doing orders of operations and then just knowing what complements, intersections, and unions are. Boy, our problems are real similar. So both of our problems start out, we're working left to right. The first thing I'm going to do in problem 54 is figure out what T union V complement is. And that's the first thing you're going to do in problem 53. So to do T union V complement, I'm going to take the set T, which is the numbers 1, 2, and 4, and V complement, which is going to be 1, 2, and 3. It's what I get when I take V out of the universal set. So we're both going to start the same way. We're going to take T, and we're going to union that with V complement. And I'm going to take those numbers and make them in a big set, cross out any duplication, write my numbers in a nice order. The T union V complement part of this, I'm going to write as the set containing 1, 2, 3, and 4. So now instead of writing T union V complement for your problem as well as my problem, I'm going to write 1, 2, 3, and 4. I'm going to have an intersection symbol. You're going to have a union symbol. Both of us need to figure out what S prime is. To figure out what the complement, I said prime because that's what I used to call this. That's when I went to grade school and learned complements. We called that prime. So I just snuck that word in there because it just instinctively read it. That's the way I learned it. To figure out what S complement is, I'm going to take 2, 4, and 6 from the universal set, and that's going to give me S complement is the set that contains the numbers 1, 3, and 5. So in place of the symbol S complement, I'm going to put that set. So I'm taking the first set that I found, and I'm going to intersect that with the set that contains the numbers 1, 3, and 5. And what they have in common, they both have 1, they both have 3. That's going to be the answer for my intersection. So for 54, my answer is going to be 1 and 3. When you go to do your 53, your set's going to go 1, 2, 3, 4, 1, 3, 5. So you're going to have the set 1, 2, 3, 4, 1, 3, 5 because you're unioning these two sets, and then you're only going to write 1, 1, and 1, 3, and you're going to get 1, 2, 3, 4, 5 for your answer to 53. One final last problem. I'm so tired of doing these. I imagine you got to be more tired than me. Let me do your 55 just again because I'm wearing out. You've got to be wearing out too. Let me do the parentheses first. And the parentheses is kind of do the V intersection T and then do the complement. Let me do V intersection T. V intersection T. V is 4, 5, and 6. T is 1, 2, and 4. V intersection T is what they have in common. It's just 4. But I'm asked to find the complement of V intersection T, and the complement of V intersection T is going to be the complement of the set that contains 4. That means to take 4 away from the universal set and write what's left. When I take 4 away from the universal set, I'm left with 1, 2, 3, 5, and 6. So the V intersection T complement, I found V intersection T, found its complement, and now I'm going to write down 1, 2, 3, 5, and 6. If I can actually do that now, I'm going to write 1, 2, 3, 5, and 6 in place of the parentheses. And now I have to figure out how to union that with the set S. So I'm going to write the 1, 2, 3, 5, and 6. I'm going to union that with the set S, which is 2, 4, and 6. When I union two sets, I take every element in the first set, in this case 1, 2, 3, 5, and 6, followed by every element in the second set, in this case 2, 4, and 6. Any duplications? I'm going to cross out one of the duplications, and I'm going to take and write the numbers in a nice order. I'm going to write 1, 2, 3, 4, 5, and 6 for my answer to your problem 55. And that's going to be it. That's the whole section in one monstrously long lecture. It's real important to get a really good handle on unions and intersections for when we move on to the next section and complements as well. So you have to have this section perfected before you go any further in the chapter.